The answer to number 14, x turns out to be 1/3. The answer to number 15, x turns out to be 17/4, or 4.25. And the answer for number 16 is x is 5. There was also an answer for number 16 of a -5, but that will not check. Okay, let's see why. So you've got a subtraction problem. So with subtraction, it means combine these and write it as a division piece. So the x would be in the numerator, the x plus 3 would be in the denominator because it's left to right. So this would be in your numerator. When with exponents you divide, you subtract. So we're putting this back in as division. My base is understood to be a 10 here, and my right side is a -1. So I now can write this in exponential form. So 10 to the -1 power will equal the x over the x plus 3. But 10 to a -1, don't forget, is 1 over 10 to the +1, or just 1/10. So let's take this proportion now and set the cross products of 10x equal to 1 times x plus 3. So 10 times x equals 1 times x plus 3, which is just x plus 3. So now we've got to get x by itself. So let's subtract x from both sides. So 10x minus 1x is 9x. And you only have a 3 left over here. And then we'll divide both sides by 9. And we find out that x is equal to 1/3. You can type this in your calculator. So you'd type, to check it, you type the log of 1/3. But you'd have to type that, just 1 divided by 3. Don't type 2 word logs. And then here, minus the log of, 1/3 is 0.3. So just take the log of 3.333. And then see if that equals this -1 that it was supposed to equal. I'm going to skip to number 16 because it's very similar to number 14 now, but it has a plus sign. So I'm going to write this as the product. So the log of x plus 3 times x minus 3. But do notice that the base is 2, and that equals the 4 on the right side. You're now ready to put this in exponential form. The base of 2 to the 4th power is going to be 16. That's going to equal x plus 3 times x minus 3, which I'm afraid is going to be a quadratic equation. So that's the sum and difference of like terms. So x times x is x squared. This minus 3x and that positive 3x adds to be 0. And then the positive 3 times the minus 3 is a minus 9. Again, 2 to the 4th is 16. You have two options. You can add 9 to both sides, and you can get 25 equals x squared, and then you can take the square root of both sides. I just want you to know that the square root of 25 is both plus and minus 5. So remember, every quadratic equation has two answers. If you did not solve this one that way, you would have taken the x squared minus 9 with the 16 on the left, and you could have subtracted 16 from both sides and gotten 0 on the left, and then x squared minus 25. Now, if you use the quadratic formula, just remember that this is a 0x right here. But I'm just going to factor this into x plus 5 and x minus 5. And I'm going to see that the two solutions for right here, x would be a -5. And the solution right here, x would be a positive 5. But remember to tell me x cannot be a negative number, because if you put a -5 in there for x, you're going to try to take the log of a -8, and the calculator is going to flip out. It just won't do that. Let's go back to this one. So the thing that's unusual about this one is that the right side doesn't have just a number, like a 4. It has the log of 5, where the base is 6. And both of these bases are the same. See the minus sign? Let's put these together as one logarithm, and let's make it a quotient. So x plus 7 over x minus 2. And then what I'd like to say to you is that if both of these have a base of 6, and they both take the log of something, this case a log of x plus 7 over x minus 2, this case a log of 5, then it should be true that the x plus 7 over the x minus 2 should equal the 5. I'm not taking these words away, like dividing both sides by log 6. What I'm saying is that the x plus 7 over the x minus 2 has to equal the 5 in order for these statements to be true. And I'm going to write that as a 5 over 1 so that I can set this cross product, 5 times x minus 2, equal to this cross product, 1 times x plus 7, which is just x plus 7, and then distribute. And then we got to solve for x, so let's subtract x from both sides, and we'll have 4x minus 10 equals 7. Let's add 10 to both sides. We'll have 4x equals 17, and then we'll divide both sides by 4 and get our solution of 17 over 4, or 4 1/4. Again, take your calculator and use the change of base theorem because of this base 6, and put the 4 1/4 for x for each of these, and check to see that it works. Let's do one more, and then we'll do the history lesson in the last video. So let's go ahead and take a look at this one. This one's very similar to the one we just did, so you could stop the video and do this yourself, because there's the word log, and they all have base 6 on both sides. This one happens to be a plus sign. So to combine these, I'm going to write this as a single logarithm, where this is the product of x plus 3 times x plus 2. And then, because these are both log base 6, it goes without saying that this expression has to equal the 20 for the statements to be true. I'm going to FOIL this because it's going to be a quadratic equation, and I can't, set x plus 3 times x plus 2 equal to 20 and not FOIL this. So I have an x squared. The 2x and the 3x I'm going to call 5x, and 3 times 2 is 6. And that equals the 20. And so now I'll subtract 20 from both sides so that I can either use the quadratic formula, or it happens that I wrote this one so that it factors as well. But if you use the quadratic formula, you'd put an a value in of this 1, you'd use a b value of 5, and a c value of a negative 14. I love how in this concluding chapter, as we're finishing up, we've worked with rational expressions again. We've done some factoring. We're using the quadratic formula. So we're using chapter 6 and chapter 7 in chapter 13. We're even using fractional exponents, which we saw in chapter 12. This problem is not quite finished. So I'm going to factor this because it's faster for me, because I know that a positive 7 times a negative 2 is this negative 14, and 7 minus 2 adds to be 5. By the zero product rule, this will give me an answer of a negative 7, which is going to be no good. But this one's going to give me an answer of a positive 2, which is going to check. Again, remember, that one's not going to work. I'm going to come back in the last segment to share with you a fun, in my opinion, history lesson of how people did things prior to 1960, which isn't all that long ago, really.